Good evening, Biology 12. So we said today in class that we are building on our knowledge that we made during yesterday's video, and so you should have already seen the macromolecule starch, protein, and lipids. And today we're going to talk about the enzymes that break them down. Starch broken into glucose, protein broken into amino acids, and lipids broken into their glycerol and the fatty acids. Again, something that we learned in our last video, starch and protein are going to be absorbed by the villi into the bloodstream, and our lipids are going to be absorbed by the villi into the lymphatic system. So when we're talking about enzymes, again, building on some prior knowledge from the units before. So hydrolytic enzyme uses water, and the water does two things. So it breaks apart our molecules, and it is then going to join the monomers that it makes. So it joins monomers, that's the H and the OH join. So let's begin with starch. Starch has three enzymes that is used to break it down. So here's our starch molecule, and we're going to begin in the mouth. And in the mouth, starch is broken down into maltose. So here's our maltose, and we know the enzyme that does this, salivary amylase. So salivary amylase is the first enzyme that is going to be breaking down starch, and this occurs in our mouth. So salivary amylase made by the mouth and is going to be used in the mouth to break it down into starch, into maltose. Optimum pH for salivary amylase to function, 6 to 7, which is the pH of our mouth. Now, not all starch is broken down in the mouth. So starch can also go to the stomach and then to the small intestine before it is either broken down from the starch or the maltose is broken down further. We will move on to starch in our second enzyme. So our second enzyme for starch is going to be the pancreatic amylase. So again, we have a starch, and starch is broken down into maltose by pancreatic amylase. The pancreatic amylase is made by our pancreas, and it's used by our small intestine. So the pancreas is going to release its pancreatic amylase into the small intestine, so the starch that wasn't broken down in the mouth can be broken down into maltose in the small intestine. Optimum pH is a 7 to 8. So now we have maltose. Maltose has to be broken down into its monomer, glucose. So glucose, again, is the monomer of starch. So maltose is broken down into glucose by maltase. So this is our third enzyme that we're going to talk about breaking down. So maltase is made by the small intestine, and it's used in the small intestine. Optimum pH, again, same as the small intestine, 7 to 8. So that's the optimum pH for the enzyme to work. So we talked about starch, let's talk about proteins now. Proteins, again, three major enzymes that are going to break down our proteins. But before we talk about the enzymes, we have to talk about the hydrochloric acid that begins this process in the stomach. So hydrochloric acid in the stomach. So the hydrochloric acid, its function is to denature the proteins. So as you can see here, the protein is denatured by the acid of the hydrochloric acid, and it basically is unfolding the protein in order for the enzyme to break it down easier. So it's the unfolding. So the second part of the hydrochloric acid, its second function, is to activate pepsinogen, which turn into pepsin. Pepsin is going to be our active enzyme, which breaks down our proteins. Not to be confused, hydrochloric acid is not an enzyme, but it is still very key in the functioning of breaking down our protein. So here we have a denatured protein. It's denatured by the hydrochloric acid. And this protein is going to be broken into a polypeptide, and like we said, in our stomach by our enzyme pepsin. So our protein in our stomach is being broken down into our polypeptide by our enzyme pepsin. So pepsin is the first enzyme that we're talking about. Pepsin is made by the stomach, and it is being used in the stomach where our polypeptides are being broken down into. Optimum pH 2 to 2.5. So the second enzyme that we're going to talk about that breaks down proteins. So we have our polypeptide again. Now this needs to be broken into a peptide before we can use it can be broken down into our amino acids. So polypeptide breaks it down again, more than 50 amino acids, breaks it into our peptide, which is less than 50 amino acids, but it is still a chain of amino acids. This is going to be done by trypsin. So trypsin is our enzyme that breaks it down into peptides, and this occurs in the small intestine. So trypsin, our enzyme, is made by the pancreas, and it is used in the small intestine. Optimal pH for the enzyme to work is 7 to 8. So now we have our polypeptide broken down into peptide, so we can now go even further and break it into our amino acids. So here's our peptide chain. We're now going to use our third enzyme in order to break down our peptide into our amino acids. And amino acids are like that chart that you guys use during translation. It is all the different amino acids that our body needs in order to make new proteins. So the whole point of breaking down our proteins is to form our amino acids so that new proteins can be made. So peptides are broken down into their amino acids by the enzyme peptidase. So peptidase is going to be made by the small intestine, and it's going to be used in the small intestine. And optimal pH of our enzyme is 7 to 8, which is the same as the small intestine. So last but not least, lipids. So with our lipids, we have a 1 star. And the 1 star means we have one enzyme, but we have another very important liquid that is used in order to break down lipids. So we call it an emulsifier, and this emulsifier is bile. So emulsification of a lipid is basically physical digestion. So we have the physical digestion of our fat, and the way that it is physically digested is that our bile is going to stick into the fat and break it up into smaller pieces in order to create a larger surface area. So our bile is our emulsifier. So here's our emulsifier. This is our bile. And our bile has our polar head and our non-polar tail. Now we know polar heads face out towards the water. Our tails then are going to stick into the lipids. So here are our nonpolar tails, they are going to stick into the fat. And when they stick in, they end up breaking it down into a bunch of small pieces. So this process is called emulsification, which basically means the physical digestion or breaking our lipid into smaller pieces. So the reason why we need our bile to do this is because it increases the surface area, which allows the enzyme activity to be increased. So bile is produced in our liver, and so our liver produces it. It goes to our gallbladder, so you can see here the gallbladder. Gallbladder is going to store it and then send it down the common bile duct into our small intestine. So it's produced by the liver, and it is going to be used in our small intestine. So that was our emulsifier. That was the plus in our 1+. Lipids have one enzyme that break them down. So we have our lipid, that's this diagram here, and it is going to be broken down into our fatty acid, which is this one, and our glycerol. And this is broken down by our one enzyme, lipase. So here you have lipase, the one enzyme. Lipase is made by the pancreas, and it's used in the small intestine. Again, pH of this enzyme for optimal functioning, 7 to 8, which is the same as our small intestine. So that's it for the enzymes. Some things to remember. There's 3 enzymes for our carbohydrate, which is our starch. There's 3 enzymes for protein, and not including our HCl, but HCl again is extremely important. And then our 1+. So 1 enzyme for lipids plus the bile, which is the emulsifier, in order to break it down for that enzyme. So tomorrow in class we are going to make a graphic organizer about this, because again, tomorrow moves on to build on top of this. So it is really important for you to have an understanding of the enzymes and where they come from and what's used and what's broken down.